Chemical reactions and chemical quantities. Calculating yields. In this tutorial, I will be going over percent yield, theoretical yield, and some worked examples. Percent yield is the ratio of the actual yield to the theoretical yield for a chemical reaction expressed as a percentage. It can also be viewed as a measure of the efficiency of a reaction. So percent yield is going to be calculated by taking the actual yield, dividing it by the theoretical yield, times 100. Actual yield is the amount of product that is produced over the course of an experiment. Many times, the actual yield does not match that of the theoretical yield due to error and outside variables. Theoretical yield is the amount of product that could form during a reaction calculated from a balanced chemical equation. It represents the maximum amount of product that could be formed from a given amount of reactant. Let's look at an example. Aluminum will react with oxygen gas according to the equation below. In one such reaction, 23.4 grams of aluminum are allowed to burn in excess oxygen. 39.3 grams of aluminum oxide are formed. What is the percentage yield? There is a lot of information that is given to us in this word problem. The first thing that we're told is the mass of aluminum involved in the chemical reaction. The second thing that we're told is that this is not a limiting reagent problem. They are specifically saying that we have excess oxygen. So we already know the amount of Al2O3 that's going to be produced is totally dependent on the mass of aluminum that we're starting with. They also tell us our actual yield because the problem states 39.3 grams of aluminum oxide are formed. So we're going to come back to this. What we need is a theoretical yield of aluminum oxide based on this mass of aluminum that we're starting with. So we're going to start with the mass of the aluminum and convert it, of course, to moles. So 23.4 grams of aluminum, multiplication sign and a line. I know that the atomic mass of aluminum is 27 grams of aluminum equals 1 mole of aluminum. But I don't want aluminum. I want the maximum amount of my product. So I need to do a mole to mole ratio here. So mole of aluminum to moles of Al2O3. Then I need to look at my balanced chemical equation and I need to look at coefficients. So there is a 2 in front of the Al2O3 and there is a 4 in front of the Al. So the last thing that I'm going to do is convert my moles of Al2O3 into the mass of Al2O3. So 1 mole of Al2O3 is equivalent to 102 grams of Al2O3. And before I plug this all into my calculator, I'm going to make sure that my units cancel. So grams, grams, moles, 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 left with mass. And when I work this out, this is going to be my theoretical yield. So 44.2 grams of Al2O3 should be produced in a perfect world where there is no error, no problems, no equipment failure, no distractions. This is my theoretical yield. So since this is my theoretical yield, I can now figure out my percentage yield because I remember that percent yield is equal to actual over theoretical times 100. The actual amount of aluminum oxide is stated here. 39.3 grams of aluminum oxide are formed. So that is my actual. So I'm going to write that first. 39.3 grams of Al2O3, and I'm going to divide that by my theoretical, which is 44.2 grams of Al2O3, and I'm going to multiply the whole thing by 100. So when I divide this out and I multiply this by 100, my percent yield is going to be 88.9%, and that is my percentage yield. So again, my actual yield was given to me. I needed to calculate my theoretical yield. I divided my actual by my theoretical and multiplied it by 100 and got my percentage yield. Let's put it all together. Magnesium oxide can be made by heating magnesium metal in the presence of oxygen. The balanced chemical equation for the reaction is magnesium plus oxygen gives you magnesium oxide. When 10.1 grams of magnesium reacts with 10.5 grams of oxygen, 11.9 grams of magnesium oxide is collected. Determine the limiting reagent, theoretical yield, and percent yield for this reaction. So this is taking everything that we learned about limiting reagent problems and also bringing in the concept of theoretical yield, which is part of the limiting reagent problem, and now percent yield. So the first thing that we're going to do is figure out the limiting reagent. They give us masses for both of our reactants. So of course we're going to do the AP chemistry mantra and convert to moles. So 10.1 grams of magnesium and 10.5 grams of O2. So I'm going to convert these into moles. So 1 mole of magnesium is equal to approximately 24.3 grams of magnesium. And if I work this out, I get 0.4156 moles of magnesium. Let's do the same thing for oxygen. 1 mole of O2 is equivalent to 32 grams of O2. So if I work this out, I'm going to get 0.328 moles of O2. Now what I need to do is take these moles and divide them each by the coefficient from the balanced equation. So I'm going to divide this by 2, and I'm going to divide the O2 by 1. So if I work this out, 0.4156 divided by 2 is going to give me 0.2078, and obviously 0.328 divided by 1 is going to be 0.328, which means the smaller of these two numbers is the magnesium, so the magnesium is going to be my limiting reagent. I have identified my limiting reagent here. Now that I have identified my limiting reagent, I can go back and I can figure out my theoretical yield, or the maximum amount of magnesium oxide that I should be able to produce. So since I know that my magnesium is my limiting reagent, I'm going to start with 10.1 grams of that. 10.1 grams of magnesium, 24.3 grams of magnesium in 1 mole of magnesium. I am going to convert from moles of magnesium to moles of MgO because I am doing a theoretical yield and I want to figure out how much product I'm going to produce. The coefficient in front of the MgO is 2. The coefficient in front of the Mg is also 2, so ultimately I'd be able to cancel those out. And then finally I need to go from moles of MgO to mass of MgO. And again, you always need to pay attention to what the problem is asking. Maybe you don't need to do this step, but in this case I'm going to. So the mass of MgO is around 40.3. And again, before I do my math, I'm going to go back and I'm going to check my units. Grams, grams, moles, moles, moles of MgO, moles of MgO. I'm left with mass of MgO. And if I work this out, I should get 16.75 grams of MgO. Now remember, this is my theoretical yield. In a perfect world, if all of my limiting reagent, which is magnesium, is consumed, this is the maximum amount of MgO that should be produced, which leads us finally to percent yield. That is the final thing that they want from this equation. So percent yield is actual over theoretical times 100. So our actual here is 11.9 grams of magnesium oxide. That is what they told us was produced during this reaction. So 11.9 grams of magnesium oxide. Our theoretical that we calculated from the previous slide was 16.75 grams of magnesium oxide times 100. The units will cancel each other out. We are left with a percentage which is roughly 71% of what we could have gotten. So this is an example of identifying a limiting reagent, figuring out your theoretical yield, you're given an actual, and finding percent yield. So what did you learn? We talked about the definition of percent yield, we talked about theoretical yield, and then we did some worked examples. Need more help? Feel free to contact me. Have a great day.